We are just discussing about important topic from the organic chemistry, and which is nothing but the fundamentals of organic reaction mechanism. In the introduction, we have studied what is meant by reaction mechanism and also types of organic reaction. Mainly, organic reactions are classified into four types: substitution, addition, elimination, and rearrangement reaction. And now, in the next part, we are just discussing about some reaction intermediates which are formed during organic reaction. Actually, to study the reaction mechanism, we must know about these things. That means what type of that organic reaction and what are the reaction intermediates which are formed during the reaction. We have already studied first two reaction intermediates, carbocation and carbanion, in detail. Now let us see next one, free radicals. This is also one of the important reaction intermediate which is formed during so many organic reaction. Now let us see introduction of that free radicals. We will see in 5 steps. First, about the introduction. Okay, consider a simple organic conversion. Suppose this is organic compound AZ. There is a covalent bond between A and Z. And suppose this bond undergo homolytic bond breaking. If there is a homolytic breaking, then during the breaking, suppose one electron from the shared pair, one electron from this covalent bond goes towards A, while another electron goes towards Z. This is the symmetrical breaking of covalent bond, and this type of breaking is called homolytic bond breaking. Now, during homolytic bond breaking, A acquire one electron, while Z acquire another electron. Okay, means A as well as Z, they are having unpaired electrons. They are having unpaired electron, and such types of the species are called free radicals. That species are called free radical. What are the characteristics of that free radical? These are highly reactive species. They can easily attack on another reagent, or they can easily combine with another free radical, and thus simply we can say that generally free radicals are highly reactive species. This is first point. Then second point, they are having unpaired electron. Then how these species are formed, how the free radicals are formed? Yes, they are formed due to homolytic bond breaking. This is third point. These are the three main points. One, yes, these are highly reactive species. Second, they are having unpaired electron, and these are formed by homolytic bond breaking. Okay, now how will you define free radicals? The highly reactive species having unpaired electron and which is formed by homolytic bond breaking is called free radical. The highly reactive species which having unpaired electron and which are formed by homolytic bond breaking is called free radical. Consider example. Okay, this is methyl free radical. Another one, chlorine having unpaired electron. Yes, it is chlorine free radical. These are the common examples of free radicals. Okay, now we can show this methyl free radical like that also. Central carbon having 3 hydrogen atoms means there is a covalent bond between carbon and hydrogen, means there are 3 covalent bonds, while that carbon having unpaired electron. Now let us see some properties regarding that free radical. Now what's about the electron deficiency, particularly in the case of free radical? What's about the electron deficiency? Is it electron deficient or electron rich species? This is central carbon. It having 3 covalent bond, means there are 6 bonded electron. This bond having 2 electrons, this bond having 2 electrons, this bond also having 2 electrons, means there are 6 bonded and one unpaired electron, and thus there are totally 7 electrons in the valence shell of carbon. Yeah, carbon च्या valence shell मध्ये how many total electrons are there in free radical? 7 electrons are there. But we know that according to the octet theory, atom should have 8 electrons, then it becomes stable. Means there is a deficiency of 1 electron. Hence simply we can say that free radicals are electron deficient species. Free radical is electron deficient species because there are only 7 electrons in its valence shell. It is electron deficient. There is 1 electron less to complete its octet, and therefore it acts as an electrophile. We know that what is meant by electrophile? Any species which having electron deficiency, it acts as an electrophile during the chemical reaction, and here it is example of electrophile. This is paramagnetic in nature because there is unpaired electron. There is unpaired electron, hence it is paramagnetic in nature. Okay, this is just about the properties of free radical. We have studied in the introduction, we have studied definition, then some example and its properties of free radical. Now let us see second step, structure of free radical. Here we are going to discuss structure of the free radical in short, but the structure of that free radical is difficult to predict. Two structures are assigned for that free radical. One is a planar and second is the pyramidal. Some free radicals having planar structure, some free radicals are having pyramidal structure. I am talking about alkyl free radical. We are talking about the alkyl free radical. Means if carbon having unpaired electron, it is alkyl free radical. Okay, now in that case, in the case of alkyl free radical, there are two types of structures which can be explained. One is a planar, some free radicals having planar structure and some having pyramidal. We will see both. First about the planar structure. Actually, that planar structure shows that hybridization of central carbon is a sp2. Suppose this is our free radical, carbon free radical, and here that central carbon having sp2 hybridization. Now, how the sp2 hybridization takes place? We know that 1s orbital and 2p orbital, they mix up and recast, and there is a formation of 3 new orbitals. Process is called sp2 hybridization, and that 3 hybrid orbitals are called sp2 hybrid orbitals. Okay, suppose this is the central carbon atom. Now that 3 hybrid orbitals, that 3 sp2 hybrid orbitals of central carbon form 3 covalent bond. Suppose this is the first covalent bond, this is the second covalent bond, and this is the third covalent bond. These 3 hybrid orbital, they form 3 covalent bonds. Okay, while there is one unhybridized orbital, and it lies perpendicular to the main plane, and unpaired electron of carbon, या कार्बनवर असणारा हा जो unpaired electron आहे, this unpaired electron is present in that 2pz orbital. Okay, this is the unpaired electron which is present in the 2pz orbital. Okay, this is actually 2pz orbital, which is unhybridized orbital, and here that unpaired electron is present in that pz orbital. Now, what's about the geometry? Hybridization is sp2, and here the geometry looks like a trigonal planar. Yes, geometry is a trigonal planar, and bond angle should be 120 degree. Example of planar free radical is a methyl free radical. Methyl free radical जो आहे means carbon which is attached to the 3 hydrogen and carbon having unpaired electron. This is methyl free radical. It is planar in nature. त्याचं जे structure आहे ते planar आहे. What's about the planar structure? First, hybridization of carbon is sp2. Then that 3 hybrid orbital form 3 covalent bond. There is one unhybridized orbital, it having unpaired electron. Third, geometry is a trigonal planar with bond angle 120 degree. An example of planar is a methyl free radical. Now let us see about the pyramidal structure. Okay, this is about planar. Let us see about the pyramidal. Here also, there is a central carbon, and hybridization of that central carbon is a sp3. Means 1s orbital and 3p orbital. They mix up and recast, and there is a formation of 4 new orbitals, and this is called sp3 hybridization. Means there are 4 sp3 hybrid orbital. Out of 4 hybrid orbital,
three hybrid orbital of carbon form a three covalent bond. Suppose this is our central carbon. It forms three covalent bond, 1, 2, and 3. How this covalent bond is formed? Due to overlapping of sp3 hybrid orbital of carbon with orbital of another atom. Okay, now that carbon also having one hybrid orbital. Suppose this is fourth hybrid orbital of carbon and it having unpaired electron. Means that unpaired electron of free radical is present in that fourth sp3 hybrid orbital. One sp3 hybrid orbital contain this. Actually, there is no lone pair of electron. There is an unpaired electron. There is no lone pair of, there is unpaired electron, and this unpaired electron is present in one of the sp3 hybrid orbital of carbon. Now, what's about the geometry? Here, this geometry is look like a pyramid, and hence the geometry is a pyramidal. Here, geometry is a pyramidal, and bond angle is reduced from standard tetrahedral bond angle to somewhat. म्हणजे स्टँडर्ड जो आहे 109 डिग्री 28 मिनिट्स तो थोडासा रिड्यूस झालेला असतो इन द केस ऑफ पिरामिडल स्ट्रक्चर. ओके, अँड एक्झाम्पल टर्शरी ब्युटिल फ्री रॅडिकल. Tertiary butyl free radical means suppose central carbon is attached to the 3-methyl group and carbon having unpaired electron, then it is tertiary butyl free radical. Then a trifluoro free radical, trifluoromethyl free radical means central carbon is attached to the 3-fluorine and carbon having unpaired electron. This is trifluoromethyl free radical. Okay, these are the examples of pyramidal free radical. The structure of that tertiary butyl free radical and trifluoromethyl free radical, these are pyramidal. Okay, this is just about the structure of free radical. Actually, the structure of this free radical is difficult to predict. Hybridization in planar is sp2, hybridization in pyramidal is sp3. Unpaired electron is present in an unhybridized 2pz orbital in the case of planar, while in the case of pyramidal, this unpaired electron is present in one sp3 hybrid orbital. Then here, geometry is a trigonal planar with bond angle 120, while in pyramidal, geometry is a pyramidal. Okay, this is just about the structure of free radicals. Now let us see next point, generation of free radicals. Means how that free radicals are generated, how that free radicals are formed during organic reaction. We know that free radicals are formed due to homolytic bond breaking. Means suppose there is a covalent bond in organic compound, and if there is a symmetrical breaking of that covalent bond, then the electrons present in that covalent bond, that means electrons from the shared pair of electron, these are equally distributed between the two atoms, and therefore there is a formation of free radicals. Means simply we can say that free radicals are formed due to homolytic bond breaking. There are different methods in which there is a formation of free radical. First one is the thermolysis. Thermo means heat, high temperature. Means at high temperature, some covalent bonds undergo homolytic bond breaking. Consider a simple example. Yes, it is benzoyl peroxide. Okay, this is example of peroxide actually. And at high temperature, just at 70 degrees Celsius temperature, the bond between that two oxygen, it undergo homolytic bond breaking. One electron from the shared pair goes towards one oxygen. Second electron from the bonded electron pair goes towards another oxygen. And there is a formation of such a species where oxygen having unpaired electron, C6H5, C double bond O, oxygen having unpaired electron. Similarly, here also C6H5, C double bond O, and this oxygen having unpaired electron. Thus, there is a formation of such two species. We are taking twice or some. Now, this free radical may be undergo again homolytic bond breaking. The bond between that carbonyl carbon as well as phenyl ring, it undergo homolytic breaking. One electron goes towards this carbon, another electron goes towards that phenyl group, and there is a formation of C6H5 having unpaired electron. This is phenyl free radical. This is phenyl free radical, while there is a formation of carbon dioxide, CO2. I have written twice CO2 and twice phenyl free radical because actually there are two molecules of that free radicals. Okay, this is just about the thermolysis, means some organic molecules maybe undergo homolytic bond breaking at high temperature, and that process is called thermolysis. There is the formation of some free radicals. Okay, let us see another examples regarding the thermolysis. Okay, this is tetraethyl lead. Okay, this is the PB. At center there is a PB, means lead, and 4 ethyl groups are attached to that lead. That compound is called as the tetraethyl lead. Now at high temperature, it undergo, yes, again homolytic bond breaking. There is a thermolysis. Here this bond undergo breaking. One electron goes towards ethyl group, another electron goes towards lead. Similarly, all the other 4 covalent bonds undergo homolytic bond breaking, and there is a formation of C2H5 having unpaired electron. Yes, this is ethyl free radical. There are 4 ethyl free radical and Pb lead metal. And this is again example of thermolysis. Okay, there is a generation of free radical. We are just discussing about the how that free radicals are generated, how they are formed. First method is the thermolysis. Let us see one more example regarding the thermolysis. Okay, this is example of azo compound N double bond N. Now this compound also on heating undergo thermolysis. There is a homolytic bond breaking. Here this bond between the carbon and nitrogen, it undergo homolytic bond breaking. Means here one electron goes towards nitrogen, one electron goes towards carbon. Similarly, there is a breaking of this bond. Here also there is homolytic bond breaking. And now one electron from the one nitrogen, another electron from this nitrogen, there is formation of pi bond between 2 nitrogen, and thus there is evolution of N2 gas. There is evolution of N2 gas. Now, this carbon having unpaired electron, here also this carbon having unpaired electron, there is a formation of that carbon free radical. Okay, there is a carbon free radical. Carbon is attached to the 2 methyl groups. Actually, 2 such species are formed during that reaction. Okay, this is the first method, thermolysis. Now, let us see photolysis. This is again a very common method in which there is a formation of, in which there is a generation of free radicals. Suppose some covalent bonds are strong and they do not easily undergo breaking by the thermal process, by the heating. Then in that case, that bonds undergo breaking in presence of light, and that is called as photolysis. The breaking of covalent bond in presence of light, then that process is a photolysis. And suppose a simple example, halogen. We consider the example of chlorine molecule. Chlorine, when exposed to the light, in presence of light, ultraviolet light specific, this bond between the 2 chlorine atoms undergo homolytic bond breaking. Here also one electron goes towards one chlorine, another towards another chlorine. First chlorine having unpaired electron, second chlorine having again unpaired electron, and there is a formation of free radical. Very easy process. Similarly, bromine also undergo photolysis in presence of light. It undergo homolytic bond breaking, and there is a formation of bromine free radical. And thus, halogen, when exposed to the light, particularly ultraviolet light, easily undergo photolysis. There is a homolytic bond breaking, and we get halogen free radical. Okay, now consider one more example. Yes, it is diazo compound. Now this diazo compound, when exposed to the light, particularly light of 320 nanometer, in presence of light, here this bond between carbon and nitrogen undergo homolytic breaking. Yes, here also the second bond undergoes same type of breaking, and there is an evolution of N2. While that carbon acquires unpaired electron, there is evolution of N2 gas. Another carbon also acquired one electron, and thus there is a formation of methyl free radical. There is a formation of methyl free radical. Yes, it is also example of photolytic reaction. This is photodecomposition, or simply we can say that yes, it is photolysis. Okay. Now let us see one more example regarding the photolysis. A very common reaction. Suppose this acetone. Acetone, when exposed to the light of 320 nanometer, then it undergo photolysis, it undergo homolytic bond breaking. The bond between that carbon as well as carbonyl carbon, it undergo homolytic breaking. One electron goes towards methyl group, another electron goes towards that carbonyl carbon, and there is a formation of CS3 having unpaired electron. Then here COCS3, that carbonyl carbon having unpaired electron. Now this species again in presence of light, the bond between that methyl group and carbon also undergo breaking, and there is formation of methyl and a methyl free radical and carbon monoxide as a final product. Thus, acetone, when exposed to the light of specific wavelength, it undergo photolysis. There is a homolytic bond breaking. We get methyl free radical and carbon monoxide as a final product. Now let us see next one. There is one more interesting reaction, a redox reaction. Consider the example of PS3 carbon. This is triphenyl methane. This is called triphenyl methane. Means this is central carbon attached to the 3-phenyl group. Now suppose that triphenyl methane on a reaction with sodium metal. Here there is just a loss of hydrogen atom. That central carbon loses one hydrogen atom, and there is a formation of carbanion. During the bond breaking between that carbon and hydrogen, this electron pair completely goes towards carbon. It acquires negative charge. There is a formation of carbanion. Now this carbanion in presence of oxygen, what happens here? There is a negative charge on the central carbon. Means there is an electron pair on the central carbon. Means there are two electrons on the central carbon. Now this central carbon loses one electron. It loses one electron, and there is a formation of PS3 central carbon now having one electron. Here there is a negative charge, means there are two electrons. But now that carbon loses one electron, and that process is called, there is a loss of electron. That process is called oxidation. Here that PS3C, that carbanion undergo oxidation. त्याचं ऑक्सिडेशन होतं and तो एक इलेक्ट्रॉन लूज करतोय, and therefore that carbon now having unpaired electron, and that species is called free radical. This is redox process because here carbanion undergo oxidation and oxygen undergo reduction. Let us see another example, very interesting reaction. Okay, this is example of active methylene compound. Suppose methylene group is attached from both sides by electron withdrawing group. Then that compound is called active methylene compound. Here this is ester group. Here also this is ester group. And these are the electron withdrawing group. Therefore, that hydrogens are acidic in nature, that hydrogens are active in nature, and that compound is called active methylene compound. When this active methylene compound comes in contact with any base, suppose there is a sodium hydride is example of base, then what happens? This active methylene group loses one hydrogen, and there is a formation of carbanion in presence of iodine. Now what happens here? Here in the second step, there is a redox reaction. Now this carbon having negative charge means there is an electron pair, means there are two electrons. Now what happens here? This carbon loses one electron. This central carbon loses one electron, and it was taken by iodine. It was taken by iodine. There is a loss of one electron. Here, now that carbon having unpaired electron, and there is a formation of free radical. Okay, this is just a formation of free radical. And here, iodine undergo reduction, and therefore this reaction is called redox reaction. Now that free radicals, such two free radicals may be combined together. अशा दोन फ्री रॅडिकलचं कॉम्बिनेशन होतं, म्हणजे इथला एक इलेक्ट्रॉन, दुसऱ्यामधला एक इलेक्ट्रॉन, आणि त्यामध्ये कोव्हलंट बॉन्ड. ओके, दिस इज द न्यू बॉन्ड फॉर्म बिटवीन टू फ्री रॅडिकल. आपण काय स्टडी केले आतापर्यंत रिगार्डिंग द फ्री रॅडिकल? इंट्रोडक्शन मीन्स डेफिनेशन अँड सम प्रॉपर्टीज ऑफ फ्री रॅडिकल. देन सेकंड पॉइंट, स्ट्रक्चर ऑफ फ्री रॅडिकल. Yes, we have predicted two structures for free radical. One is a planar and second is the pyramidal. Okay, then third point is the generation of free radical. Generally, that free radicals are generated due to homolytic bond breaking. First method, thermolysis. Second, photolysis. Third one, redox reaction.